Well, hello again, guys. We're looking at lesson 2 in the course in the lessons that we have to finish up before we get to finish the GCC credit. And today we're going to start talking about trig. All right, and specifically, we're going to be talking about the unit circle. All right, now the unit circle for trigonometry has the equation x squared plus y squared equals 1. All right, where the center is 0, 0, and the radius is 1. So that unit circle, all right, is centered around the origin. I wish I could draw circles better, but that one's not too bad. All right, so when we're working with this unit circle, the basic idea of trigonometry is the study of triangles. So we basically were drawing triangles inside this circle. At least that is the idea of what's going on. All right. So the starting point for us is the point 1, 0, right? And the default direction is counterclockwise. So that's why this is where it came from, that the coordinates, or excuse me, the quadrants are labeled 1, and then we get to 2. We keep going around the unit circle, then we get to 3, all right, and we go around the unit circle some more, and we finish up our circle after passing through quadrant 4. All right, so this is kind of embedded in math in a lot of different places. All right, so the first thing we're going to do is to draw angles in standard position. All right, so if they ask us to draw the angle 75 degrees, all right, so we're going to look at our unit circle. We're going to start at the point 1, 0, and we're going to go counterclockwise 75 degrees. Now, going all the way to the y-axis, right, would be 90 degrees, so we didn't go that far. We stopped 15 degrees shy of hitting that y-axis. All right, so then we draw what's called the terminal side, and the terminal side is a ray that starts at the origin and goes through the terminal point. The terminal point is basically where you run out of degrees as you're drawing that 75 degrees in standard position. All right, so if I go further, let's try to draw 200. I mean, not try, we're going to just do it. Draw 200 in standard position. All right, we start at that same point. It's a positive angle. All right, so we go around the unit circle. All right, there's 90, there's 180, and we got to go 20 degrees more till we get to our terminal point, and then we draw the terminal side through it. Okay, so that would be 200 degrees in standard position. All right, now sometimes the angles are negative. All right, and for a negative angle, the only difference is we're going to go the different direction on the unit circle. We're still going to start at 1, 0, but we go clockwise instead of counterclockwise. All right, so there's 90, and I've got to go 10 more degrees. All right, so I'm estimating that terminal point where that is, just so you're close. You're in the correct quadrant, right, and closest to the correct axis. All right, so that would be negative 100 drawn in standard position. All right, so how's the first lesson in trig going so far? Pretty good? I hope. Okay, now the next thing we're going to do, as we work around that unit circle, we have two different forms of measurement. Okay, so as I go around this, I can measure in degrees, which is what you're used to, all right? And Another way of measuring is called radians. All right. It's very similar to inches and centimeters. All right. So it's just two different forms of measuring. What we're going to do is we're going to go back and forth between those. All right. So 180 degrees is equal to pi radians. All right. Now remember, pi has the value 3.14. All right. So we're just going to work with the pi. All right. So if I have 60 degrees and I want to go to radian measure, all right, we are going to take that 60, we're going to put it over 1, and we're going to multiply it by pi over 180. All right. Now, pi over 180 is a form of 1, right? Pi radians is equal to 180 degrees. All right, so what I'm going to do then is I'm just going to, well, you can multiply top times top over bottom times bottom, right? Numerator times numerator over denominator times denominator. But when you do that, you can simplify first. So if I cross off that 0, that's just like dividing 60 and 180 by 10, right? Now it's easier to see 6 goes into 18 3 times. So I've got 1 times pi over 1 times 3, right? And 60 degrees is pi over 3 radians. All right, so underneath that, we're going to change 240 degrees to radians. All right, so we take the degree measure, we put it over 1, and we multiply by pi over 180. All right, I'm going to divide the 180 and 240 by 10. And then I notice 6 goes into both of those. So 4 times pi over 1 times 3. All right, so that's degrees to radians. All right, I also could go from radians to degrees. So if I wanted to go with the radian measure 3 pi over 4 and change that to degrees. All right, I'm going to take the 3 pi over 4, multiply it by a form of 1 that will get rid of that pi. So all I do is I multiply by 180 over pi instead of pi over 180. This way, the pi's cross out, all right, and then I could do 3 times 180 divided by 4, right? Or if I simplify, 4 goes into 180, 20, 4 goes into 16. I could use a calculator, but that's cheating. 4 times, 45 times. And that's, all right, so now 3 times 45 is 135 degrees. Okay, so 3 pi over 4 radians is 135 degrees. All right, so try to find another one that's not on the other side without looking. Let's see. How about 5 pi over 12? That's already there. That's cheating. Okay, so I'm going to do 7 pi over 12. Where is my whiteout tape? All right, so I'm going to multiply that by 180 over pi. All right, the pi's divide out. All right, 12 and 180, 6 goes into both of those. All right, remember that's a 7. And then 12 actually would have divided into 180 15 times. All right, so now numerator times numerator, 7 times 15 over 1 times 1. Or just 7 times 15. 105 degrees. Okay, so changing from radians to degrees and degrees to radians, and drawing in standard position. Those are the things that we need to be able to do. All right, so the first one under the examples, it says to draw the following angles in standard position, so 75 degrees. All right, I'm going to start at my point 10. Hey, look at that, I chose the same number again. Huh. All right, 15 degrees away from the y-axis. So 75 degrees in standard position looks like that. All right, the one underneath it, negative 300. All right, it's negative, so instead of going counterclockwise, I go clockwise. All right, and I've got 90, 180, 270. Boy, that's a really bad looking circle. And I'm going to be 60 degrees shy of making a whole circle. All right. Question number 5. Change to radian measure. All right, so when I'm given a degree measure, I put that over 1, and I multiply by pi over 180. All right, so we divide by 10 to get rid of the zeros, and numerator times numerator over denominator times denominator. 5 pi over 18, which doesn't simplify. All right. So the nice thing, guys, about this, if you're having some questions and you need to watch something over again, you can kind of rewind, go back, and see how things are done. All right. So 210, I put the degree over 1, and I multiply by pi over 180. All right, so I divide to simplify and make this a little bit easier. Divide by 10, get rid of those zeros. And I notice 3 divides into 21 and 18. So numerator times numerator over denominator times denominator. Okay, so 210 degrees is the same as 7 pi over 6 radians. All right, and then the last ones, change to degree measure. All right, so I'm in radian measure. See if I can zoom in on this so it's a little bit easier to see. So I'm going to multiply by 180 over pi, which is a form of 1. And this way the pi's will divide out. All right, so 6 goes into 180 30 times, and 7 times 30 is 210 degrees. Sound familiar? Yeah, backwards of what we just did. All right, and number 11, 3 pi over 2, it's radian. They want to go to degree measure, so I multiply by 180 over pi. All right, my pi's divide out. 2 goes into 180 90 times, and 90 times 3 is 270 degrees. Okay, not so bad. Hopefully not anyway. All right, and then things don't always stay too easy. All right, so looking at number 1, it says to draw in standard position, and I've got 700 degrees. All right, now, if you think about it, 360 degrees is all the way around the unit circle. Right? So what we do to show that we've gone around more than once is that we kind of elongate our circle a little bit. Now, I know the real circle is just a circle, and I would keep going. It's just hard to see that way. All right, so I'm going to subtract the 360 that I used up in that first circle. And yeah, I know you can do that over your head. I think it's 340 in your head. All right, so I got 340 degrees left. That's going to be 20 degrees away from making another whole circle. So I just go around again, and I'm going to stop 20 degrees away from making a second circle, draw my terminal side. It's kind of hard when you can't see the dot. All right. but that's okay. I don't take off for artwork. All right, number 2 says to draw in standard position, but I've got a radian measure. Now, I don't know about you. I've been working with radian measure for a long time now, and I still would not want to draw in standard position in radian measure. I'm going to change that to degrees first. All right, and then I will draw it in standard position. Okay, so I'm going to let you guys finish that one up. Your homework assignment is just going to be to finish the notes and send that to me. All right. Number 3, change to radian measure. All right, so I've got a degree measure. So the difference is all here in the next level is just the numbers get bigger. All right, I want to multiply that by pi over 180. All right, divide by 10, get rid of those zeros. Notice 6 goes in to 60 10 times, and 6 goes into 18 3 times. So now numerator times numerator over denominator times denominator. 10 pi over 3. All right, and I'm going to leave you number 4. I'll give you a hint, though. Just multiply by 180 over pi. All right, so hopefully this one wasn't too bad. Lesson 2 of 6 that we have to do. And let me know if you have any questions, and I'll be happy to give you some assistance. All right, have a good day, guys.